morning. Okay, we're getting to the end of the engine. I think 3D physics is like one of the last must-haves of the engine now. I'm gonna turn off this music. So far we've got full 2D and 3D rendering. 2D and 3D like vector math. We've got procedural mesh and terrain generation. We've got 2D physics with soft body joints. Yeah, I mean, like, we've got mesh batching. I think that just 3D physics now. The one other thing for 3D games and like 2D games that's also super useful is pathfinding, or some navigation. Like most engines use navigation meshes. I've been really thinking about something that can work with a procedural solution as well, where you don't pre-compute, you don't take a bunch of time to pre-compute a navigation mesh. But I think that's something you do after 3D physics. And for a lot of games, you can just get away with just predefining your own path nodes, like very simply through, find that's the most efficient thing through buildings and things, is you go, okay, this node goes to here, and then like the way pathfinding solutions normally work is through nodes. So then once you already have a list of nodes, it's so easy to just apply an existing pathfinding solution to those nodes that you've created. And personally, as a game dev, I do not mind going through and placing nodes, but for a procedural solution, that's the really weird thing, is like if you have really complex procedurally generated areas, you can't really use nodes. Like, I don't know. Like, that's the other weird thing too, is the way the nodes work as well, is it's normally expecting that it's a player or some specific object size walking through. But the issue is that if you don't have, like, if you have so any super small object will work, but like if you try and have like a big enemy or something that's way bigger than the player, then it might not necessarily fit through. So then you get this complicated system where you actually have the nodes have to have like almost like a distance field type map of how much the minimum distance going from one node, or like the minimum gap in an area going from one node to the other that it, like a character object can fit through. That's why I think, like, I don't know how to apply that to a procedural. I almost feel like that's something that neural networks would actually approach very well. Oh yeah, I saw a really cool shader this morning. Maybe we'll go through it right now. I've gone through these people's shaders on stream a few times before. This guy Michael, and I think there's another one by Wyatt. But they do insanely good particle dynamic. I don't even know. Simulations, cellular automata. Hold on, I just want to go back to the newest one that I haven't seen yet. He's been really active. He did Jupiter 2.0. Another blue noise gen. Oh, is this like Gabber noise or what? Close to Gabber noise, yeah. Oh my god, he has done, so I think superfluid helium was the last one I saw, yeah. Superfluid helium here, so I don't know, let's check out these virtual slime molds. Virtual biological stuff, much slime. Actually, I have seen this. Is this using the particles? Yeah, if I had to guess, these are particles, and then it's like storing them in a buffer. Save particle. Interesting. Let's look at save particle. This is where the main part of the code actually is. Diffusion and advection. Great position. Add weighted by mass. Oh, okay, so I already checked out the new shader he did today, and this is the part that's different in the new shader. I don't know if we'll just go straight to that, because the new shader is really cool. Just looking to see. Most of these are really nice. This has a nice rotating. So I guess this has vortices, or these are almost like vortices. Yeah, this one is really nice looking. And I like how fast it is. Sense oscillation. Interesting. Slime mold sensors. Alright, I want to see this emergence of life one. No, really? What the heck? Fascinating emergent system. Oh, wow. This one has a lot of buffers too. Hey, Morame. Cat is just straight up meowing at me. I know you are. Okay, maybe it wants out. Hold on. Oh my god. Okay, this is good though. I want to let this emergence of life shader run. I want to see if this actually does anything other than wiggle around. Dude, my cat can scream. Like... Oh, so this is based off the slime mold sensor stuff again, too. I just deleted the life. Nah, this isn't that complex life, at least it looks like. Unless... Like, that's the thing. This right here could actually be some complex computation. I'm not sure, though. Like, that's the crazy thing about this, is you never know what's at, like, computing the exact values one by one in here. But yeah, it doesn't seem like they evolve or anything. Like, it seems like they're fixed. Vorticity confinement. Oh my god, is he actually detecting vortices? Like, pretty big ones, too. Hacking particle. Pressure gradient. So this is all based off the slime mold sensing. Huh. I wonder I feel like he's calling it slime mold sensing, but like it's actually it must be something else. Alright, anyways. Okay, I want to see this cell system one too. This is really cool. No, really, what the heck? Huh. Talk about particles in physics. Love WebGL Unified Particle System. What is WebGL Unified Particle System? Yeah, all of these are based off particle fields. WebGL Unified Particle System. Oh. Eh. This isn't that amazing. This is not that amazing. I bet this breaks down when you have a ton of objects across a very large area. Like it doesn't, like across WebGL, you can't have really like how it's all in volume shapes. You can't have like really complex stuff, and because they have to do Verlet integrate. Yeah, it's simple. You have to do Verlet integration on the GPU here. So if things move really fast, they'll go through each other, or you have to limit the speed or increase the iteration count to an insane amount. Like this here, that actually same thing happens here. So this is the shader I've been talking about. Molecular dynamics. This is really interesting. I still don't understand how exactly it does the attraction. I believe the attraction happens right here. Compute the force. Like I really don't understand. This transfers the velocity, or sorry, this transfers the mass, which also ends up transferring the velocity between connected cells. And this is the main part that's actually changed between his last shaders of all these. This is the main part he added new. So he says that it's now with perfect particle number conservation, so I'm thinking this is what does the perfect conservation now. And it's really interesting to me because he said that I asked him about it, and he said that it doesn't matter that this is horizontal or vertical. This just splits the mass across horizontal cells or particles, which is really interesting to me. Like it only splits mass horizontally and not vertically. And like I tried it vertically here, and it doesn't work because this function or you can see now it'll actually cause them to like stick together. Actually, maybe it will. So this particle distribution function, it's made specifically to work. Hold on, where is this? It's made to work on the x-axis. I should. Okay, you can see here now objects get stuck in the air. Yeah. Oh yeah, it has a bug where things can clip through the top and bottom right now. Graph network of particles. They find each other by searching a directional graph. Yeah. I was talking about Wyatt stuff. It's interesting how they break up. Do they reform back together completely? Oh no, I broke the letters. Do they form back together? I think they do. By searching a directional graph. They clip through each other though. If you watch, they do just pass through each other. Hold on, hold on. I love this guy's picture. Use your mouse to make your own wax sculpture. Classic. Where's his last particle physics? Convolution theorem? Frequency space repetition made by multiple signals together. I don't know what he's doing, but between the title and what we see, I'm repeating the drawing and frequency space. You can multiply two signals together in frequency space to convolve them. I take the Fourier transform of the letters, multiply it iteratively by a KFS Fourier transform, and then project it back to phase space. It's just a really complicated Fourier transform used to shift. I've never seen Fourier transform been used like this. This guy's kind of crazy in the stuff that he does. Low toner. Forward advanced compressible fluid simulation with 3 texture philic surfaces. So many crazy coders on ShaderToy. Man, there's so many crazy mathematicians that have just had this stuff in their head for years, and now they're just like, I can just write this out in 100 lines of shader code. I want to see this 4 substance one. I've been waiting for people to do particle physics that has multiple types. Meandering currents. Look at them go. This one's gonna smack into the wall. You ever seen that video of the manatee that just like goes straight into the window? That's what that current just did. Alright, I should actually work on my physics engine. Or substance. Forwarded vector compressible fluid system with 4 repulsive substances. Repulsive substances? What kind of substances are they? Blood, green stuff, magical goo, white stuff. Now, what's the purple stuff? I guess he just means repulsive by they repel each other. Oh yeah, Rory's the other one. Man, I remember the names of these people that do the other particle physics shaders. This is really nicely rendered. Like, oh my god, the performance of this. Fast Fourier transform chaos game. Interactive drawing of chaos game. Fractal, use the mouse to move around vertices. Left and right arrows to... Wait. It's the up and down arrows, which is brightness. Left and right arrows to add points. That doesn't seem to work. Oh, maybe it's because the brightness is too high. Interesting. I have a 2D demo game with GPU physics and WebGL made some time ago. Like, nah, it's all good. I need to stop looking at these. It's just like, oh my god. Dragon fast forward transform dragon curves. I did a dragon curve shader a really long time ago. Plotting values of Littlewood polynomials. This guy's really good at math. I can't find the really cool ones. Alright. Oh, man. Yeah, the shaders, I don't know. So here's the thing. I make some shaders that I don't understand completely. So, like, sometimes I just expect, hey, maybe the devs don't even understand them completely. But then again, those people are so goddamn smart. They probably do. They probably do understand them. So, I think I'm just gonna start with a new 3D example and just do physics 3D example. Dude, someone was like, I told someone that you just need to like slowly practice each day and you get better at shaders. And they were like, oh yeah, it's totally like day 1, code a line. Day 1,000, code realistic human skin with pores and everything. And I was like, no, it's like day 0 is like you draw a flat color. A line is like day 10 if you're good. Some people don't get a line till like day 20, day 30, because line is like complicated vector math. But then, I probably completely lied to that guy, because then I was like, wait, how did I progress shaders? Wait, what the hell? Oh, this isn't newest. First day, a custom gradient. Actually, what's the time between these? Oh, 117. Yeah, so these are both on the same day. I did this like 3 hours later. I found out about shaders, so I'm like, these are cool. And then I'm like, alright, toxic sludge. So then, 22, just 5 days later, I made a really shitty ray tracer. And this isn't like copying other people's code. This isn't a distance field ray tracer. I don't know if you look at the code here. It's so goddamn bad because I had no idea what I was doing. Like, look at this. So instead of like, I have the height map, right? But instead what I do is I do a trace at a high resolution where I check if it's smaller than the height, jumping at big steps, and then once it finds it at like after doing big steps, it steps back and then does a trace at or at higher resolution. Actually, I think this is higher resolution trace. I can't remember how it works. But it's dirty as hell, but it works. But the performance is horrible. But like shadows, reflections, and like janky ray tracing. So, I mean, and then I think like 3 days later after that, I had distance field tracing. Or like 4 days later, I had a basic distance field scene. So man, I feel like shaders are so good for learning. Like so good for learning. Because I'm like, so this is the thing, like, you say you did not understand shaders in like 2 years. I would say I was the same for me. Like, I just learned like so much over my first year or two of doing shaders. I almost want to say I learned more doing shaders than like any other thing from programming. Alright, I'm just looking here. I'm going to use the procedural primitives as like spheres and stuff for shapes for the physics. And then physics3d.js. So to begin, just going to copy physics 2D. And let's begin. So one of the things I've been thinking about for 3D is that in 2D I only have two base collider shapes, circle and box, and I was like, oh, I'll do some more advanced shapes for 3D, but I thought about it and it's like, nah, box and sphere just cover the basics of collider shapes. The other one I actually thought of doing is line, because that's also like a capsule. Doing a line distance field with the rounded edges. I think that would be good, but that same shape could be covered by a box. So that's why I'm like... Then though, this custom collider, the one thing I can't figure out if I want to change. Capsule is 2 spheres, so that's the thing. If I program the collider myself, it's actually just 1 sphere that is actually like, it's like a torus where the sphere is like warped to the nearest point across the line, clamped to the line. At least that's how like the capsule line distance function works. So I've got this thing here where it takes the normal and okay, so this is the weird thing about calculating the normals from these distance functions. The sphere is easy because it's just the center, but the box can be rotated, so you have to first rotate the position when it's relative to the box, sample the distance, or like in this case I actually just straight up calculate the direction to the box's edge, and then you actually need to rotate that direction back again afterwards, because you're basically converting, this is basically converting world to object space, and then this is converting the object normal back to world normal. And like for this custom collider, I've been thinking about this because I could just make it so that you don't need to program this rotation in yourself. I just do the rotate inverse beforehand and then rotate the normal afterwards, so the custom collider could automatically support rotation. Like, this is the thing that I feel like was really stupid. So this is basically what I'm choosing between the optimization of having rotation automatically be applied to custom distance functions, or sorry, I said that wrong. The optimization of letting you choose inside the distance function whether or not you want to apply a rotation, because then, like, if you're not rotating it, it's going to actually make it way more efficient to not do the rotation transform every time you sample it. But then you have to program that in each time you want to do it. Whereas like this, I could add in it automatically at the cost of performance. I feel like it's not hard to do, so I'm just gonna leave it like this, and if people, like, if you want to do a rotation in your transform, it's insanely easy to do. You know what? I'm just gonna expect everyone's gonna want to do rotations, because I mean, why wouldn't you want to rotate your objects at times? So let's just apply. Oh, this is really weird though. Hmm. Hmm. So I'm thinking about, in the future, applying this to a mesh collider or a distance field volume. I guess the X and Y will still be the center of where it rotates around. So I'm just thinking, the way this currently works is the custom distance function is actually fed in the world position, because then if it wants to do any custom sampling from the world position, it can do that. But I'm actually thinking that local position would just be better, because then you actually need to access less data from the custom distance function. One of the birds out there is just going like, woo, woo. And then the other, the dove is standing there cocking its head like, what? Birds are funny. Alright, so like this custom distance function. Um, okay, I'm actually going to change this around. Oh my god, I'm an idiot. I'm an idiot. So here, I am sampling it. I am passing in the position relative to the object. That's inconsistent. Okay, I'm gonna pass in the custom data afterwards, because some functions might not use the custom data. I need to go get water. I just want to switch this around in the 2D version. So yeah, this custom normal, I just realized all of this can actually be the same. This is what I do at the beginning for all of them. Nice. Okay, so now this X and Y is in local space. So I do have the option for a custom normal function if you don't want to do distance derivative. So one of the things that I've been thinking about, like distance, with the custom distance field, like if I was doing an actual distance field volume, the custom normal would basically just be the derivative. Like, I really wish I could figure out some way to put the triangles in like a lookup table. Hold on, I'm gonna Google while I'm thinking about this. Look up triangles for sine distance field. Maybe someone's done this I think someone's done this exact same thing, but probably not with the same limits that I have. Hmm. Most efficient way to calculate an SDF to a triangle mesh. Actual Stack Overflow question. This is nice. Say I build an. There's no answer to this question. Say I build an access line bounding box tree around all the triangles, then given grid points, search for the closest leaf, compute Euclidean distance to the triangle. So the issue that I found with this axis aligned bounding box tree approach is that you try and find the closest leaf, but the issue is that two leaves might actually be nearly equal distance, and then inside the leaf, the triangles are a bit offset, and one leaf that's actually a bit closer actually doesn't have the closest triangle. It's one that's a bit farther away, has a bit farther away bounding box, but then actually has a triangle that's positioned so that it's closer. Like, that's the issue I found, is that the axis aligned bounding box tree actually gives incorrect distance fields. Can I actually look at the source code of this? Project calculates approximate SDFs for triangle meshes. Approximate SDFs. This example creates 250,000 points where most of the points are close to the surface and some are sampled uniformly. Deep SDF. Oh yeah, this is a really cool idea. But I don't know how you do this efficiently. Yeah, I guess KD tree. It just seems like it would take up so much memory. Oh, and this uses does this use mesh to voxels? Oof. So I'm looking for something that doesn't. You know what? I could just convert to voxels first, and this would just be way easier. Actually, huh? Yeah, if I just convert to voxels, then an AABB tree would work. Okay. I'm just looking at this. The sample's the normal. Epsilon of 1e negative 8. Normalizes it. Everything looks good. And then afterwards we need to rotate back. Okay, so this is already an F buff, so I actually need to do F buff 0 and F buff 1. I think that's good. So that should take the position, put it completely to object space, put it back to world space. Alright. There's some stuff like that that I'm probably going to end up changing it when I start actually using that custom distance function. I just realized I'm also not passing in all the data when I call it here. Okay, so this should be pretty simple. We're just going to be adding a third Z component. There's no rotation or quaternions in this system. That's all given from the joint physics. Like this whole thing of connecting all the rigid bodies. So this is a really untraditional physics system. All the rigid bodies are circles or spheres, which, so you said capsule, Nomura, you said capsules are two spheres, or yeah, like in this physics engine, literally the only way you can do capsule rigid bodies is by combining two spheres or circles. And it actually has a system for that, these extra colliders. You can actually combine as many spheres or circles you want to make whatever shape you want of rigid body. Obviously, it just adds a lot more performance to every one of these that you add. But it is super flexible. So even though each of the rigid bodies doesn't have any rotation by itself, if you combine them in a joint system, like this soft body, now you have rotation. And it also comes along with soft body physics and a bunch of nice stuff. Alright, hold on 1 second. Also, I think I'm gonna... Oh, man. I don't know how I feel about music. It's kind of like... Some people don't like it. Some people like it. I almost feel like nothing is just better. Alright. Yeah, I think I am gonna put music on. So I talked about this the other day. I program way slower when I just talk about all this stuff. Like, describe everything I do before I type it. I kind of just want to get this. This 3D physics is basically a copy of the 2D physics I already did on stream before, so I think I'm just gonna concentrate and just try and finish this. Because I am really excited to get to the point where I could just like make games with this. And then there's like some really polish kind of things that I think are like polishing for the engine, like getting an editor. I'm not going to do like the traditional visual editor from Engine, how there's like there's components and people can make their own components. And this is just going to be objects. Like, the editor is just going to be placing objects that you've already made in your code. So this is really going to be an engine for programmers. But that's exactly what it is. That's what it's my engine, because I'm a programmer. Man, YouTube suggestions are so bad. It's like, it's a catastrophe. You watch one thing and your recommendations, like you watch one lo-fi song or something, and your recommendations are just all lo-fi suggestions. It's broken. It's actually broken. Okay, hold on. What do I do to break this up? Alright, I'm just going through a giant amount of different songs. And we're just gonna get the YouTube recommendations refreshed, hopefully. Good enough. Here we go. Oh, this is going to be a really big number. So this is the indexing of the spatial lookup table for the physics. And right now, it scales up to 20,000 times 20,000, which is... $400 million, which is pretty brutal. But I mean, I kind of like taking advantage of JavaScript 64-bit numbers. I'm just thinking, I think this is correct. I'm just thinking how big this will get to now. So then we can have 20,000 times 20,000 times 20,000. So this is the max index for the lookup table, which I think is okay. That's a really big number. That's like 8 quadrillion. Shit, man. Wait. What's the max array index in JavaScript? Oh, wait. I'm not doing object index. Am I? I'm doing object indexing. Okay, this is actually fine. This is fine because I'm doing object indexing. Huh. I wonder if I should make this smaller for 3D. I think I'm just gonna leave it, and if I run into issues... See, I feel like I might run into precision issues with these big numbers. I was thinking if it went to 1,000 instead. It would still be 8 billion. I think if it's all integers, you won't run into precision issues. Like, hold on, let me try this. Plus... okay, it looks like it works. Man, JavaScript having 64-bit numbers is actually kind of nice. You don't feel bad for doing big double precision 64-bit precision. Well, hold on. Is there any performance hit? JavaScript performance hit of bigger numbers? Does it do any compression, or are numbers always 64-bit? Oh, this looks like what I'm talking about. So modern JavaScript runtimes and compilers perform an optimization called small integers. All numbers in JavaScript are double precision floating points, which are relatively small to perform calculations on. However, in practice, all the cases in for loops are working with integers, so it's very useful to optimize numbers to perform efficient calculations when possible. When the engine can prove that a number is a small integer, it will gladly treat it as such to perform all calculations. Okay, I hope it does. Wow, this is interesting. It's actually give us straight up assembly. Check tag bit to ensure x is a small integer. So they actually have a tag bit in each number. That's brutal. Sea of nodes. Man, JavaScript virtual machines are disgusting. Oh. Actually, scale X is only used for spheres. I wonder if I should add an extra check here that goes if sphere. No, I think you should just change scale X, Y, and Z, actually.
I think I found a bug.
Why does it do plus 10,000 here? And plus 9. Oh, I get it. Because it increments. it increments it each time here because it loops through. Never mind, I get it. It's scanning the lookup table and scanning the nearby corners of the lookup table. I feel like I should try and contain this to 32-bit integers, but it's really not possible without limiting it to like an 100 by 100 block. So I think what I might do is I might start out with this, and then I might, when I'm benchmarking performance later, because I'm gonna do a test where I spawn a whole bunch of particles. Then I'm going to test the performance difference of limiting it to a 32-bit range. This might not be correct. I'm not certain. Also, this could actually just be done with like this, I think. Yeah, I'm thinking how I'm going to debug this. What I did do at one point was I just sampled the distance function at a bunch of set points, knowing what it should give at those points. I think I might just set up an example like that. It's cool going over this. I'm finding little changes that I can actually improve in the 2D physics as I go over the 3D physics, changing it from 2D to 3D. Yeah, I actually found a bug here with the extra colliders. It's not supposed to add them, it's supposed to subtract their position here. I just realized these custom distance and the square actually both do the rotation before and after. I don't know if this is worth optimizing by combining these. Like doing something like that's actually the same, and then it has less calls. That's really good. Alright, I'm going to change the 2D physics to work like that as well. Because it seems like a much nicer way of doing it. Jesus Christ, dude. The nicest part about distance fields and ray marking are the extending from 2 to 3 dimensions. It's like exactly the same. You literally just add a Z component. I mean, I get when you get to like more complex geometry like meshes, obviously it's different, but like, man, just the base distance field marching code though. Nice. Alright, I'm gonna go get some breakfast. I'll be right back. I'm hoping to get this example done in like the next hour, so we can actually get a little example going, maybe some like particle physics. Alright, I believe all the vector math that I've done here just extends to 3D. I think like all the reflection stuff here is just dot product stuff, so I don't believe that anything should really change when I switch this to 3D, but I might be wrong. I'm just realizing I can actually optimize this as well. Huh. Yeah, I can store velocity x and velocity y in a buffer. I'm just thinking if that's really worth it. Yeah, I'm not going to worry about optimizing at the moment. Oh yeah, I should put something saying that mass can't be 0. Yeah, people will figure out when their objects disappear from existence. Okay, that should be it. I wonder if that'll compile and work. That should be the basis for the physics engine. So now let's start programming the actual example. Thinking how I'm going to do any lighting or visualization in this, I guess. I guess I might try and do like a cube viewed from the outside, so you can see through one half of it. I think I have coalesce. Yeah, I have coalesce. Also, I want to check what are the defaults for culling on the materials. I keep forgetting this. Default is less, I believe. Yeah, default is cull back. Default is depth right. Default is depth test. Okay, so I actually don't need any of these for this example. I just need to mark the shaders example.glsl here. And I need to prepare it so that I have a procedural mesh for the cubes. I need a procedural cube mesh, and I need a procedural sphere mesh. Okay. And I don't think I need the mesh builder for either of these, because I'm not going to do what I did in this last tutorial where I combined, or example where I combined a circle of meshes. Yeah, I actually might not use the mesh builder. I'm thinking the only thing I need that for is flat normals. I don't think I'm gonna do flat normals. I think I'm just gonna do, because the sphere is gonna be rounded, and I mean like the outer cube doesn't really matter. So let's generate primitive cube. I think I have a primitive to mesh function. Procedural primitives. Primitive to mesh, yep. Okay. And what are the default options for the normal and all that? No normals, no tangent. Okay, I want normals. So the primitive cube, that's not the size, it's the number of triangles in the cube. Alright, so hold on, I'm gonna do boundary cube. I guess I'm just gonna do these separately. So I'm just gonna get the material, because we're just using one material for this whole thing. Do I use... I think I do return assets here. Yeah, okay. So the asset system, you have to manually say when you're not using assets anymore, and I automatically have that in the systems in the systems that do load assets themselves, but I need to remember to do that. I should almost make an example where I just show that specifically. Alright, so now I'm going to set up a simple example where you just have a camera you control with the mouse and can rotate around. I can't remember if I need to use rotate 3D or rotate inverse for this. This is a yawn pitch. I think I need to do rotate 3D. Oh, I need to do if mouse down. It's just moving the camera for every mouse movement. Alright, so this is our... okay, something is broken. It's weird, the camera yaw keeps resetting to 0. Oh my god, I'm an idiot. I'm doing equals instead of plus equals. 0. There we go. It actually I actually did something first try. Okay. So this is us viewing our cube from the outside. I want to try and maybe flip the normals somehow. So that we view it from the outside. Yeah, so we're supposed to see through this cube right now. Although I'm thinking, screw this. It'll just be easy to just see the spheres that we're using through that. So I'm just thinking, do I want to maybe just copy the similar code from here? Alright, so I guess I'll make the boundary colliders. Alright, let me do this as... I copied this in, so I should do this first. So testing at the beginning here, there's really going to be no spatial lookup optimization. It's going to be like n-body. If we have 100 particles, it's going to be checking all 100 against each other every iteration. I just realized I should also set the physics delta to something. Maybe 100 is a decent tick rate. Also, we're going to need to loop through and apply gravity as a dither. Do we do that here? Because, I actually explain here. There's no gravity dither because the gravity doesn't have to compete with input forces. Oh, okay. So yeah, you only need a gravity dither when you have like a player that you're trying to get. Gravity dither actually adds... It basically lets it iterate separately on the gravity and input forces so that they don't just counteract each other. It makes it easier to move players and have things slide across each other. But for a simple particle example like this, it shouldn't really matter, I don't think. So we're just going to set the scenery to sphere mesh. I just realized I set this to triangles here. Wait a minute. No, never mind. Alright, so I need to set up my boundaries, spawn the particles, and I need to create sphere primitive to use as particle mesh. Generate primitive sphere. How many... Oh yeah, I forgot. You use the cube function to generate a sphere. That's kind of a confusing thing I did. Okay. Oop. So that generates a sphere primitive, and that converts it to a mesh from the buffer. And now we'll create the boundary colliders. I don't know if I can do this in a for loop, or... I guess I'll just do it separately? Physics Collider 3D. Shape equals box. I'm gonna make it 10 across. Okay, yeah, so I'm gonna create a function for doing this. Realize, do I not enable physics here? Oh, I have to wait for the prototypes to be added first, I think. Wait. Enable physics. I don't know, let me try it. Alright. So that creates the boundary colliders. Now we just need to spawn in our particles, I believe, and apply our physics tick. I'm also looking if there's a way to calculate the physics ticks per second from this. I might just count if it's just losing frame rate. Alright, and when I benchmark this, I am going to turn off the rendering at a certain point, so we are just benchmarking the physics. So now I need to at least create one particle. I'm thinking I'm just going to spawn in one particle to begin. Should be a nice little... new particle. We'll just put it at 0, 0, 0. It should just fall. Oh yeah, I need to apply gravity. Apply gravity force to all bodies. Yeah, there's some janky things about this physics engine. I mean, like, see, not applying gravity is kind of janky, but at the same time it's also an optimization. Because if you're not doing gravity, or you want to do some custom gravity, then having like the built-in gravity and having to either apply like opposing forces to cancel that out or something, it's just not good. So just loop through, add to the Y velocity. I just built the wrong example, so it didn't do anything. I'm thinking this is going to throw errors and not actually work. Alright, it said there were 500,000 ticks. Oh, I have to reset tick time. Wow, I think it just... I'm surprised it didn't completely lag. Rotate inverse 3D. Let's reset tick time or not reset tick time. Oops. Oh. Wait, what was that? Shape is not defined. Hit 100 ticks per second until it lagged the hell out. Also, do I have the right rendering here? Distance scaling. Shape is not defined. Oh. I actually made that same error in the physics 2D. No. What? Okay, so the camera isn't going away far enough. It's actually clipping into the sphere. What do I have that's scaling? Oh, I'm doing just scale X, Y, and Z. Or scale X and Y. I kept it in 2D without scaling the Z. Here we go. Alright, it's really hard to see, but this is a bouncing particle, the point. I think bounce and friction are both 1 by default. Bounce and friction are both 1. So, I guess I'm just gonna spawn in a bunch of particles now, so you can actually kind of see what's going on. This is looking good. It's looking like it's working so far. I'm just going to do a very small example. Again, I don't know. Just looping through the X, Y, and Z. I think I'll spawn in like 27 to begin, which seems like a decent number, but it's not really at all. So I'm just printing out how many bodies there are in the console at the beginning as well. Yeah, 27, okay. So I think I either need to increase the field of view. Oh, this is cool. This is a really cool example I set up. Because they're perfectly aligned, they just bounce up off each other. Yeah, so I think I either need to make the field of view smaller. Yeah, I think the solution here is just to make the field of view smaller. I don't know, let's try 60 field of view. Really small, but... There we go, it's alright. Oh, okay, that's actually an issue. How do I get it to fit the whole thing into the screen? How do I stop it from bouncing down like this? That would actually be field of view way bigger, wouldn't it? That might be too much field of view now. That's kind of cool. Alright, I need to apply tiny jitters. Hold on, let's check the frame rate. So it's still a solid 100 ticks per second. Let's try applying some tiny little bits of noise to this, so that they now bounce around randomly. The box might be way too big for them. It's the thing right now. Yeah, so it looks like a bunch of them are just slowly bouncing and getting stuck in corners. I don't know, let's, I mean, everything's working so far, so... Let me think about these. These are one distance apart. This actually might be too much jitter. So I'm just gonna do 0.1. Anyways, let's actually benchmark it now. I'm thinking maybe 10,000 bodies. Try and get it to a point. I think I'm just thinking this starts at -10. It'll clip into the wall right there. So we have to go to 9. But I think this should be 20 times 20, 400 times 20. And not quite 10,000. 68. 6859. Okay. Alright, nice. It's lagging. Good. This is good. Lag is good. We're trying to make it lag to benchmark. So disable the rendering. Disable all the rendering so that it should make it way faster, hopefully. See how much the rendering had to do with the optimization. Okay, it's still pretty brutal. I'll be happy if I'm able to support 10,000 bodies in this. So it seems to me like the rendering is not at all... if I just disable the physics, I just want to make sure the rendering here is working. Yeah, so the rendering is absolutely flawless. Can render, so... How would I up this to even more? Do plus equal 0.5 in one of them? This should double it. Should double the number to like 12,000 or 13. Oh, 0 bodies. Derp. I guess I need to count manually. $13,000 bodies, rendering with no lag. How many polygons are these? Is this triangle mesh? Because this actually isn't. This sphere mesh looks really good for how many triangles it is. I think. How many triangles is it? I can't remember. How do I get the procedural size? Here we go. Oh, actually it's index count divided by 3. So I'm gonna try to increase this to get it to a point where it's lagging, because I really just want to see... Okay, so 144 triangles in the sphere mesh. So 144 times 13718. That's like a million. That's a million triangles. That's pretty good. So let me see about reducing the triangle count. Okay, so that makes them sphere or cubes. That makes them And 48 tries, pretty good. Okay. I don't know how smooth I should make them. Anyways, let's just keep ramping up this number until we get lag. This is crazy. Oh, this actually isn't testing frame rate right now. Wait a minute. I think it's actually losing frames a little bit right now. Okay, yeah, so 50,000 objects gives 30 frames per second. I am very happy with that with WebGL. 50,000 objects for WebGL. I'm fairly certain I can get more than that if I enable frustum culling. There's no frustum culling enabled right now. I'm curious how number of triangles affects this. I don't think it's going to that much. Yeah, so it's still 30 FPS. I'm fairly certain the slow part of this is all the draw calls, and not the actual meshes being rendered to the GPU. So that's a really good test. I'm really happy with that. Let's just convert this back. So this just confirms kind of what I already knew. The rendering is really good. And this is also without Google Closure Compiler, which actually does a lot of optimization for JavaScript. Closure Compiler will take a bunch of variables in the renderer and make them constant. It will also change a bunch of accessors from being arrays to being object keys. Like, it's actually so nice. So, alright, let's test the actual physics now. So, now the question is, how many can I support? How many objects can I support even without collisions? Like, what if I disable collisions? Hold on. I think it still has to loop through the objects. I think it still needs to loop through all the surrounding objects, which will still make it pretty slow. But let's see, if we change the collision mask to 1 and the layer to 2, it won't collide with itself. And we should see the particles just pass through each other. Okay, that is still very laggy. So obviously it is the whole act of looping through all the objects that are in that surrounding area. So what to do to optimize that? We can reduce this physics 3D unit size to more accurately fit the spheres, and then it'll batch spheres together in the lookup table. Like right now the lookup table is actually bigger, like the cell of the lookup table is bigger than the whole area that the spheres are in, so there's no lookup table optimization. So now what we're going to do is we're going to change this lookup. We're going to implement the lookup table optimization on like a really nice scale, because the spheres are 0.1. We could easily do a lookup table cell size of 1. So this will actually be good benchmarking for... This might crash, I'm not sure why, but we'll figure it out. So it looks like it's executing a little bit faster now. Hold on, I want to look at this physics 2D map size. Because I'm fairly certain the reason it's lagging so much is this physics 3D map has gotten giant. It might be the 64-bit array access that I was talking about. Oh my god, I wonder if it's the 64-bit access. It is physics 3D map, right? Yeah, it is. So I think you can tell from how long it's taking to output this physics 3D map. Yeah, so how many objects are there in this? Okay, I think this is what's making it so slow. Okay, I shouldn't have opened that. But yeah, I'm fairly certain having to access the map with 64-bit indexes is killing the performance. So this, the 2D version, actually fit inside 32-bit integers. So, let me try. I'm gonna try changing that, and we'll see if we get better performance. Because I'm noticing most of this lag is coming from the, like, making the lookup table cell size actually fit or spread between many different bodies is actually making it lag huge at the beginning, I think. It's really hard to tell because it's kind of just lagging anyways. It's lit. Yeah. Okay. I guess initializing all these particles and setting up the map really kills performance. So I gotta think about this. So I guess what I'm going to do is I'm going to modify this to fit. Hold on. I can just disable the Z portion of this, which will limit it to a 32-bit value, and this will actually just check my theory of if it's killing performance just from being a 64-bit value. It's not getting the small integer performance in JavaScript. Okay, it actually looks like it's running a little bit quicker now. How about now? Oh, it actually looks a little bit faster. Okay, that improved performance a little bit. Huh. It actually does just make complete sense, though, if JavaScript isn't able to process 6,000 bodies, but I'm fairly certain... So part of the issue, I think, with this type of system is it will just keep trying to process more and more even when it can't hit the frame rate. So I'm going to try and lower the frame rate to something like 10 that it can hit. Web page is slowing down. Yeah, see, this is what I'm talking about, is it's... Okay, let's try and get 1 frame per second. Yeah, you can see that chop when it tries to process the physics step. And it looks like multiple of the particles have gotten stuck inside each other. I wonder if that's from me doing this. I feel like I should just disable this at the beginning. But I don't know. I want to see if this fixes it. Oh, yeah, okay. See, are any stuck together? Yeah, it actually looks like a few are stuck together. I definitely think there's a bug in this current system. I need to get it working optimally though. I guess maybe I'll try lowering the map size here, but that's the other thing. I can't figure out what size. What's the low size I can set it to while also being within the 32-bit range? The values get so big so quickly. Oh, so that actually looks like exactly 1 billion. Okay, so I think I might make it go to 1,000 in 3D. Hold on, I'll be right back. Okay. Let's find out where this is actually coming from. I just remembered I added a part of this code here, if layer, if the particle doesn't have a layer, then, oh, my door might slam from the wind, then it's not going to collide with anything. So they should just fall through each other now. So let's check physics 3D map. Yep, so the map is empty now. So let's see, with just updating the objects, can we get 50 FPS? Okay, so just updating 6,000 objects. Okay, I definitely feel like I should zoom the camera out. So I'm curious, can I improve performance? So one of the things about distance fields is there's like the epsilon, right? Or marking. The epsilon is based off the particle size, so 0.1 is technically the epsilon, but I have a theory that changing the thickness of the bounding boxes also has the same effect as increasing the epsilon. Because it's like increasing the other side of the thickness. I don't know, I didn't really see any change in performance there. Either way, it seems like 5,000 objects is like the 60 FPS limit. Let's try and get solid 24 FPS, the cinema. Yeah, so we can get basically 24 FPS with this. Now what if we decrease this to an insanely small value? Did we get any objects passing through the floor? Does it change performance at all? No, it doesn't. It does not. Okay. Alright, so that's good. So that basically confirms what I thought, is that the performance is coming from whatever it's doing here when it searches all of the nearby. I think this part's broken. I said I thought this part was broken, and I'm pretty sure it's broken. Oh, it is broken because I changed this. Just gotta think about this. So it adds to the Y, because the Y is across 1,000 units. It subtracts 3 because it's already added 3 through here, resetting back to the beginning. This adds the Z, which is across 1,000,000, and it subtracts 1,000 times 3 to go back on the Y. Okay. Oh, but what about the -3 here? I guess that's fine. All right. So I'm going to lower the objects a little bit, or lower the count. And then I'm going to introduce collisions. And I might make the objects a bit bigger, because I guess I want to make it obvious that they're colliding each other. So how many bodies are there now? 1,000 bodies. Okay, I like this test. Alright, so this should lag. Whoa. Oh, it looks like there's a bug in my physics code. Whatever happened here, it has just started locking up. So I wonder what happens there. I definitely think there's a bug in the code. I don't know, I want to get it working with a little small example first. So it works good here. And then one of them goes flying there at a super high velocity and it lags the whole thing. I'm really curious what that was. If I think that might be an issue with my collision code, or it might be something here. I don't know, like this thing. So that's the thing, these are all centered around the map actually. So,
Well, did you notice what's wrong with me? No, I can't even breathe. When my head's low.
oh, this is plus 500 instead of 499.
Well, I can feel it again. This loss is slowly crushing me. All this pain suffering. Why need you back in my arms? After all this pain suffering.
Okay, that's looking...
Do you like my frown? I had a smile once. You turned it upside down. Make amends with me. No,
What are their velocities? Because I see they're bouncing a little bit. Velocity X, velocity Y, velocity Z. Is the velocity going up? No, okay, it seems stable. So now the goal is, let's see about performance. Also, I just realized I have a little bit of a fog here. I wonder, should I keep that in? This is a really stupid thing to just edit the shaders right now, but... I'm just going to keep the Lambert lighting. So first thing I'm going to try is actually reducing the lookup table. It's actually a decent size. Oh my god, it's smooth. It worked. It works. It works! We got physics. Okay, now to benchmark the hell out of this. So let's try and get 100 frames per second. Okay, we've got 100. It's kind of trading frame rate for tick rate now. But it's all good, it's all good. Very happy with the engine so far. This is really good. Alright, I think I'm gonna ramp it up slowly. So 1900 bodies now. Starting to get a little bit of lag. Oh my god, it's still holding. Holding? Holding 24 FPS. Wow. Okay. Last step. This is where it should break down and start lagging. 6,000 bodies. 6859 to be specific. So it's actually running the full 24 ticks per second. It's just beginning to drop frame rate in exchange for that. Like you can see, it's actually freezing the screen here because it just starts looping. I'm going to try and fix this so it doesn't freeze if it starts lagging, because I believe I can actually detect this. Like, I actually don't think this is lagging too bad. You can see it's still running. It's just favoring... It's just if the physics takes over all of the processing, it doesn't give any time for mouse events or anything. So like right here, I set the limit of after it lags for 2 seconds, it resets. I think 2 seconds is perfect because like you do it a bit too much and it can actually cause people's like physics to mess up. Well, it doesn't cause like non-determinism. It causes time to like misalign, if that makes sense. Okay, so then the next step here is what if we can optimize this more? What if there's a better value here for the lookup table chunk size? It's lagging so bad I can't even open up the next page. Oh, this seems worse. It seems like it's allocating a ton of stuff at the beginning here. I guess 6,000... I wonder if it has to free the memory of the past. It's really weird to me how it lags one time when I'm opening it, and then another time when I open it, it doesn't lag at all. Yeah, this is interesting, because I wouldn't think it would lag this much just initializing 6,000 bodies, but maybe I'm wrong. Something about the max size being 2, maybe? Oh, it's the tick rate. Did I change something about... So that made the performance worse. I believe this is the smallest we can set set it to without causing issues. I just ran the wrong example. Oof. Yeah, so I think I found the right... I think 1 here was good before. I don't know, let's try making it even smaller, see if that'll work. Okay, actually getting better performance now from that. It just froze again. So yeah, this is actually what I already knew about the JavaScript processing, is that it will just completely lock up your browser if the physics ends up taking more iterations than like the rendering and all that. Let's set it to, I think 1000 N body is a really good example. And I actually want to test some of the RAM requirements for this. So is this 1000? Yeah, 1000 bodies. Physics 3D map. So the map should be like 1000 big. It looks 1000 big. Object.keys, physics 3D map, .length. 5,000 keys. Let me think of the math about that. Unit of 1. That ends up stretching across to 2. Think? No, yeah, that actually stretches across 1. So 20 units times 20 times 20 is 8,000. Actually, it's impressive it only has 5,000 and not fully 8,000. So, I really like this example, but it's kind of boring how they all just fall to the bottom there, so I think what I can do is if I just set friction to 0, they'll just keep bouncing forever. I want to make this an actual cool example. Here we go. So now it's almost like a fluid physics type thing. Beautiful. Okay. I'm gonna go now. I got some stuff to do this morning. I'm gonna be back this afternoon, I think, with mesh collisions. And I think I might try and do like a first-person controller to explore like the mesh body world. Because I don't want to do another particle physics example. But yeah, we're gonna be doing more physics engine stuff again later. This is just a simple example to 1, benchmark performance, and 2, to just like make sure that the physics is working properly. We were checking to make sure that none of these are colliding with each other and getting stuck. They're all moving and they're not passing through each other. It's actually beautiful. And actually one thing that I haven't tested for a while, and I mean it could always break, I don't think it's broken yet, but one of the key things about this physics engine is that when things move really fast, they don't get stuck. They can just move at incredibly high speeds. So, what we're gonna do is, we're gonna make the particles move insanely fast just to benchmark this. Okay, so what should happen is that these should never pass through the walls. They should stay contained in this box no matter how fast we make this go. The downside of this is that as objects move faster, they're actually slower. And they'll actually get stuck at collision points if you make it happen too... I don't know how to explain it. If your frame rate's too low, it'll look like objects are getting stuck against walls and things. So what should end up happening here is that they shouldn't really appear faster because their speed limit is limited by the tick... Not the tick rate, it's limited by the distance to the bounds. But it should get laggier and laggier. So what we're going to be doing here is we're just going to be looking at the positions and just making sure none of them go through the walls. So far they're all good, all the positions. So the position here, the X and Y, should be within 10 units. And it's really good so far. It looks... This is the last one. Oh, this is the last one. Okay, yep, they're all contained. So let's just do some insane value that it should lag with. So 1,000,000 units. This should probably lag because it has to process so many iterations. Never mind, it's good. Okay. I'm insanely happy with this physics engine. It's actually just working. It just works. This is the greatest thing for me, is not having to worry about objects ever going through walls. Like, I cannot tell you how many times with PhysX in like Unity or Unreal Engine I've just had stuff just go through walls. Just unexpectedly. Not unexpectedly, but like even when I have continuous collision detection on, if things go too fast, they will go through. And I believe it's just like the way Verlet integration works, the way they do PhysX. Oh god, I did too many. It's gonna lag. Alright, here we go. There's our example. I'm so happy with this. I was really worried when I started seeing those bugs this morning that I was going to try to convert the 2D physics to 3D and it just wasn't going to work. There was going to be some... Like, I know in my head that the math adds up, but still I have that thing of doubt where I'm like, I can never predict all the different variables and ways that things can go. So, like, there can always be issues and things, but, like, to have it actually line up today and have it just work like this, I'm very happy with an 1000 N-body at 60 FPS in JavaScript in browser. That seems really good to me. And with soft body physics, very nice. Alright, that'll be it for the stream this morning. Just wanted to get that base physics system working, because now the actual hard part, I think, begins. Mesh physics, or mesh collision. And because I'm using distance fields, I think that's going to be particularly difficult because I need a mesh distance field, which is, it's very slow to calculate distance to triangle. So we'll see about that. I think it'll be fine. I have a few ideas of a solution. I think I could do a rough bounding volume hierarchy. I can also do a distance field volume. The issue is going to be making it quick to calculate and low on RAM. I don't know if there's going to be any solution that actually fits those. So, SAT algo, is that an SDF algorithm? SAT algo. Boolean satisfiability. Is this in logic and computer science, the Boolean oh my god. The problem of determining if there exists an interpretation that satisfies a given Boolean formula. This sounds like something mathematicians do where it's all theoretical, and then when you actually try and program it, it's fucking horrible. Extension that has gained significant popularity is satisfiability modulo theories that enrich CNF formulas with linear constraints and raise all different constraints. Uninterpreted functions match that as the majority make the formula true. Yeah, I don't know. I don't know. Wait. Why does it have divide and conquered here? Separated access algorithm. Oh, okay. Wait. Parallel divide and conquer tries to split the search space between processing elements. This is super ambiguous. Or it's like really generalized stuff. Boolean satisfiability. Satisfiability. That's something I don't say all the time. Alright, let's see. Separating axis theorem is a method to determine if two convex shapes are intersecting. Is this like point and... This sounds like point and polygon. This sounds like point and polygon. Separate rather. In one version, both these sets are closed. There's a hyperplane between them. Yeah, this is insanely hard to calculate, though. Separating axis is always a line. For example, in 3D space, the space is separated by planes. So the issue, I think, with this, each faces normal or other feature direction. Okay, this is so goddamn slow, because then you have to loop between each face and each mesh, with each other face in each mesh. And it becomes like an n by n problem that's insanely big. Possible separating axis, not separating lines of planes. Huh. So I think the issue with this... Yeah, so first of all, it doesn't work. I'm gonna be doing non-convex shapes. It only works with convex. And I need exact distance. I need minimum distance, and the plane doesn't give me that. The hyperplane doesn't give me that, because like even with a like one object and another, and if I got like a hyperplane here between them, it works fine if they're like perfectly lined. Like, doesn't this not give you the exact distance? Maybe I'm thinking about this wrong, but like, yeah, so I guess that actually you're right. This does work for convex shapes. This works fine for convex shapes, you're right. But yeah, I specifically want mesh collision because it's non-convex, and I want to just be able to throw in just any 3D mesh and just have it work for collisions. That's a huge thing I want in the engine. Anyways, that'll be it for today. Or, not today, that'll be it for now. I'll be back in like 2-3 hours maybe. Maybe a bit more. At some point today we're going to be doing mesh collision. Hopefully it'll work. Maybe it won't. Either way, I'll get it eventually, because... I mean, okay, here's the thing. I'm going to get mesh collision, but it's probably going to be janky and buggy, and that's going to be the issue. That's how programming works. It's not like an absolute thing of you get it or not. It's like, it kind of works, but it's janky, and you just kind of got to make it less janky. Thanks for watching me make this janky physics engine. I'll see you around. If you have any questions, I'm on Discord, Twitter, wherever. Hope you have a good day, good evening, good afternoon, wherever you are.